Okay, use the following information for these questions 14 to 16. That's pretty important to read in the exams. So we're doing these exam questions. Make sure you do that, notice that, because it means that there's information in some of it that you might require for any of those questions between there. So the table below shows the long-term average of the number of meals served at each day at a restaurant. And it also shows the daily seasonal index from Monday to Friday. Okay, so the first question was the seasonal index for Wednesday is 0.84. So this tells us that on average the number of meals served on Wednesday is. So that is simply us just interpreting a seasonal index of 0.84. So what does that mean? Is it above or below average? It's below by how much? 16%. Good. So it's 16% less than the daily average. That's that one. Okay, so question 15, it says last Tuesday 108 meals were served. So as soon as I read that, because they're telling me what actually happened on Tuesday, I like to go, right, then that must be an actual for a Tuesday, because it may help me when I'm trying to work out what they asked me. So the deseasonalized value, so highlight these words. They say the deseasonalized value for Tuesday. So I'm going to write the formula for deseasonalized. So deseasonalized is when you do the actual over the seasonal index. And see, once I've done that, I go, oh, sweet, they gave me the actual. I saw that in the question, and I must be able to get the seasonal index. So up at the beginning, they said this table can be used for questions 14 to 16. So I need to go and get Tuesday's seasonal index, which is 0.71. So we'll do 108 divided by 0.71. Okay, it is going to be 152. Now, because Tuesday's seasonal index was below average, when I deseasonalize the data, I should see a number bigger than 108. Okay, so you could have got rid of, saying that it had to be bigger than 108, I could have got rid of those ones straight off the bat. But anyway, we've worked it out and it's E. Okay, question 16. Now, the seasonal index for Saturday is closest to. So previously, in previous exams, they only had one seasonal index missing. And so it's a little bit easier, because if you remember yesterday, I said when you add up all the seasonal indices, you should actually get the number of seasons you've got. So because this is days of the week, these would have all added up to 7. So when there's only one missing, you can subtract all the rest and know what it should be. But this year, they started to push it a little bit more. And they said, no, there's 2 missing. So the only way for us to work out the seasonal index for Saturday is to actually do the whole process of it. So let's go and write. So seasonal index formula is the actual over the seasonal average. Okay, so if you just go back in your notes, you'll see that. And so how do I find a seasonal average? I have to add them all up, and I will divide by 7 to get the seasonal average. So we're going to do that on our calculator. I got the seasonal average to be 131. So therefore, when I go to the seasonal index, Saturday actually was 190 and the seasonal average was 131. So we end up with 190 divided by 131. So we get a seasonal index of 1.45. Okay, so the table below shows the long-term average of maximum daily temperatures for summer, autumn, winter and spring. The seasonal indices for summer and winter are missing. the seasonal index for winter is. So this is obviously out of a trial exam, and because that exam question we just did before was done. So I'll give you a little bit of time. You go do it. Okay, so you had to calculate the seasonal average, which meant I had to add all these up and divide by 4, and I got 20.3. And obviously the seasonal index formula is here. So what actually happened on winter was 12.6, and it's obviously the seasonal average was 20.3, which I just worked out. So I end up with an answer of C. Okay. Is this for repeat? Oh no. The table below shows the long-term daily temperature for summer, autumn, winter and spring. Seasonal indices are missing. Okay, in 2021, the deseasonalized average maximum daily temperature in autumn was 22.2. So remember, write formulas. So deseasonalized was actual over seasonal index, and what they just gave you was this 22. This is the deseasonalized. So the actual temperature, if you remember, we had a formula for reseasonalizing, which was actual equals deseasonalized times seasonal index. So for this one, 22.2 times the seasonal index for autumn, which they did give us, is 0.98. So 22.2 times 0.98 was 21.75. So where's that one? 21.8 is what they rounded it to. Okay, so in this one, the retail fashion sales for a large department store during spring has a seasonal index, so spring, and a seasonal index of 1.25. Now, to allow the effects of seasonality, highlight these words, allow the effects of seasonality. What that means is, what they're trying to say is when you deseasonalize the data, when you deseasonalize the data, what happens? So they're saying to allow for the effects. So when you deseasonalize the data, are you increasing or decreasing by a percentage? Okay, so remember we did these yesterday, and I said to you, we're going to make up an actual, yeah, and we see what happens. So if you look at the formula for deseasonalize, so deseasonalize is actual over seasonal index. So we want to know what happened. So I'm making up this actual of 100. So I'm making it up because I'm using 100 because they're talking about percentage. So I can see how this 100 changes. So if I do 100 and I divide it by spring seasonal index there, which is 1.25, I'll end up with a value of 80. So my number went from 100 down to 80. So what happened there? We decrease by 20%. Okay, so it is that one. Okay, you can already know if your seasonal index is above average, you're going to be decreasing. So you could have got rid of these guys, and then you have to make sure that you decrease by. What do you think the most common error is there? Is kids just say, oh, you decrease by 25% because it's 1.25. That's not right, okay? And we're seeing it. When we do deseasonalize, it doesn't decrease by that amount. Okay, so here we go in the next one. It says the seasonal index for summer is 0.8. So you can see they give me summer's seasonal index. And then it says to correct for seasonality. So this is another way of saying when you deseasonalize. So they could use correct for seasonality or they could say allow the effects of seasonality when you deseasonalize. I'm just going to say what happens, yeah? So that's what that means, okay? So once again, we could write our formula and, okay, maybe make a little note. I'm making up this 100, up the value 100, just because a lot of people go, oh, where'd you get that? And then we're going to divide it by the 0.8, and we're going to end up with 125. Okay, so we went from 100 to 125. So what did we do? We increase by 25. Okay, so there you go. And as I said, you already know it's under average. It has to go up. So you could have got rid of the 3 reduced, and you were down to a 50-50. But they're pretty easy to work out, and they don't repeat. So this is, see how it says question 12, question 12? That's 2 different exams of the same, and the question. They put it in question 12. And if I go to this one, question 16. So this was the last question of the exam. So they're thinking it's hard again, because kids are constantly getting this wrong. So the seasonal index for the sales of cold drinks in a shop is in January, is 1.6. To correct for seasonality, to correct the January sales. So can you see for seasonality? So we know that means it's if we deseasonalize, yeah? If we deseasonalize, what happens? Okay. That's what that means. So it's very similar wording now. So deseasonalize is actual over seasonal index. So we're going to make up that 100, and we're going to divide it by January's 1.6. So what does that give me? It's going to go down, isn't it? Because it's above average. So it went to 62.5. So I started 100 and I went down to 62.5. What did I drop by? I decreased by, what was it? 37.5. Okay, if you're a bit sure, 100 minus 62.5 equals 37.5. That's what we're doing there. Okay, so it reduced by 37.5. All right, next one. Let's have a read. It says, the table below shows the number of visitors in an art gallery during summer, autumn, winter, spring quarters for the years of 2017 to 2019. The quarter average is shown for all these years. The seasonal index for summer is closest to. So, this one you have to, so we've got to work out summer. So what you have to do is, for every summer, the 3 years of summer, you have to find the seasonal index, and then you have to average it out, yeah? And this data is written in a different way to yesterday. So I'm going to do summer seasonal index of 2017. And just over here, I'll just write, remember, seasonal index equals actual over seasonal average. Okay, so for 2017, summer had an actual of 29685, and then I divided it by the average, which they did give me there, so 27194. So I don't have to work that bit out, and I'm going to get an answer. So the summer index for 2018, here's the actual, 25420. They give me the seasonal average at the bottom, 23183.5, and I'll get the answer. And then I'll have to do summer seasonal index for 2019, which is going to be, it actually had 31496 divided by its seasonal average, which was 29243, and we're going to get an answer. Because I got 3 decimal places, I'm going to write mine in 3 decimal places. 1096. Right, so once you have the 3 of them, you then got to average them out to get the overall summer seasonal index. So we're going to add them up and divide by 3, and that will get us our answer. So I get 1.088, so we get that answer.